Now let's talk about a higher order derivatives. What if you have a derivative that can be done twice, 3 times, or 4 times, which means when we have the regular derivative, that's a derivative from the type 1. You are deriving one time for that function. But if you want to derive the function twice, then you would say it is a higher order derivative. Like a derivative from the second order means you are deriving the function twice. A derivative from the third order, you are deriving the function 3 times, and so on. So if you have a function that looks like this, you're having y equal the function f of x that equals x to the power of 5 minus 3x to the power of 4 plus x. When we say higher order derivatives, we're not saying higher order for the variables that are included in the function, like in this case x to the power 5 or power of 4. That's higher order function. But a higher order derivative means instead of having only f prime as a first derivative, you can have f double prime, f triple prime, quadruple prime, and so on. So in this case, if we have f prime, we're already pros in that now. Easily we can say the f prime of x for the function that's known in here equals 5x to the power of 4 minus 12 multiplied by x to the power of 3 plus 1 minus 12 multiplied by x to the power of 3 plus 1 in this case. Now what if we need to have the second derivative for this function? You basically derive it twice. That's what it means. So you can go, first you do the f prime, you get the answer, then you do a derivative for the f prime, then the solution would be the f double prime or the second order derivative of that function. Same as the f prime of x, we said it can be represented as dy over dx, or the f double prime of x can be represented as d over dx the f prime of x. So that's saying it is f double prime or the second order derivative of the function f of x. Only those are fancy names, don't get scared about them. The important is the concept. Just identify if you get f double prime, you're gonna derive the function first and derive that derivative again, then your final answer would be this way. So f double prime here is the first derivative of the f prime. So we derive that function twice by deriving it the first derivative, then deriving the first derivative again, that give you the second derivative. So here 5x to the power of 4, 4 by 5 would be 20x to the power of 3 minus 36x squared, and the 1 is a constant, will go away in the second derivative. As easy as that, nothing to be scared about. Now we have y double prime equals 20x to the power of 3 minus 30x to the power of 2. That's the second prime as we saw previously. Now the third derivative, what would be for that function? You just derive this function again. So 20 by 3x to the power of 2, that's 60x to the power of 2 minus 36 by 2 is 72, and x to the power of 2 minus 1 will be x. The fourth derivative of that function would be the derivative of this. The fifth derivative of that function would be the derivative of this for one time. As you can see, you can call it the third derivative here, fourth derivative, fifth derivative, or the derivative from the order 5, or the fifth order derivative of that function. As easy as that. There's a different representation for the higher order derivative. You can see it this way. If you have f of x, you can say it's almost like to the power of 4 between parentheses. That is saying this is the fourth derivative of the function f of x. Then sometimes you see d3 of y over dx cube. That means it is the third derivative of y, or in other words, it is the y triple prime, or it is f of x triple prime, f of x 3 times in short story. And so on and so on and so on, all the way to f of n of x equals blah blah blah. As easy as that. Now let's take an example. You have here y equals 1 over x. Find the d square of y over dx squared What he is saying find me the y double prime, or he is saying find me the f double prime of x, knowing that f of x equals 1 over x. As easy as that. What we do, as we learned before, f of x is 1 over x. What is the f prime of x? Going back to the table, you can know the f prime of x would be minus 1 over x squared. What is the f double prime of x? That equals 2 over x cubed. Maybe this is a bad example because it's a little advanced and needs a table, but as we saw previously in the linear function, it is easy. Just do the first derivative, second derivative, third derivative as needed. Be able to interpret and read what the question is telling you. Here it's telling you find y double prime, which means derive the function twice. Another example, y equals x to the power 2 plus 10x to the power 20. As you remember, that's a chain rule. Find y prime, find y double prime. He's getting straight here. If we want to find y prime, then that would be 20 of the parentheses to the power 19 multiplied by the derivative of what's inside the parentheses. Doing that again, that will give you this answer. Of course, that's a y prime. Now y double prime, what would it be? It would be 40 by 19 by x squared plus 10x to the power of 18 multiplied by x plus 5 multiplied by 2x plus 10. You see here, these are two functions, by the way. So what you do in derivative of two functions, you derive the first by the second as it is, what we did here, then plus, you derive the second, the derivative is 1, multiplied by the first as it is, which is x squared plus 10x to the power of 19. And that would be your final solution for the y double prime.